Alright, so basically what we're looking at on page 371 are the two equations, formulas for making an equation, right? There are two formulas. One is y equals mx plus b, right? And the other one is y minus y1 equals x. Oh yeah, m. Is it m? There's an m too? Yes, that's right. It's m. There's no b. It's just m. M times x minus x1. Alright. And both of these, hi, welcome. Both of these you start with an m and a point, x, y. Right?
Yes.
They give you a slope and they give you a point, and you need to find what is the equation for the line. Alright? So let's look at some of the first ones. We'll just start with number 1. So I'll just block that off. This is what we're doing. So number 1, it says that our point is 1 and minus 2, and our slope is minus 4. Okay. And for number 1, they want us to solve it with the first equation, the first formula. So what we do is we have m, and we need to solve for b.
Yeah.
Right? So we basically say y, so we're going to do y equals mx plus b. And now y we have from this point. Because we know this point is on the line. So if we put these values in the line, it will work. Because it's an equation. So we know that this is equal.
Yes.
That if y is minus 2 and x is 1, this equation will be true.
Yes.
So we can substitute it in. So we take y is minus 2, so we put minus 2 here. And m here is minus 4.
Yes.
We put that here.
-1.
And x is 1 plus b. So now b is the only unknown, right? Which is what we want. You always want to get only one unknown, and then you can solve for it. So here we say minus 2. What is minus 4 times 1?
-4.
Minus 4 plus b. Right? To get rid of this 4, it's minus 4, what do we do?
Plus
We
4.
have to add 4 to both sides,
Yes.
right? So we add 4 here, we add 4 here. These cancel. Minus 2 plus 4?
2.
2.
B equal 2.
So b equals 2. 2 equals b, or b equals 2. Okay. So now actually, we have m, and we have b. And we just need the equation in that format. We keep y and x,
Yes.
right? Because the equation has y and x. So we just put them in. So that means y equals m is minus 4, right? Minus 4
X
x, and then b
plus 2.
is 2, so it's plus 2. That's our equation. Okay? That's what because we have m, they give us m in the beginning, and we solve for b. And we just put those things in this equation. And that's the solution. And if you want, you can check. You can put these 2 points in here, right? So if you want to check, you can say minus 2 equals minus 4 times 1 plus 2, right? So this becomes minus 2 equals minus 4 plus 2, which equals minus 2. All right, check. So you know this is the correct equation. Okay?
But in the first here, the minus 2, which is x, y.
This is y, because remember our points? They're always x, y.
Okay.
It's a coordinate point,
Yes, yes.
right? That's very important. You have to keep track. The first one is x. The second one is y. Always. And if you think about it, in the alphabet, x comes before y,
Yeah.
right?
Yes.
So A, B, C, D, F, G, H, W, X, Y, right? So X, Y, in that order. All right, let's do another one like this. Let's try number. We can try number 2. Yeah, we can try number 2 because Imad, you're saying you had trouble with that as well, so we'll do that one too.
-1
Minus 1, minus 4, and what is our slope?
and slope is 2.
M equals 2. Okay, you know when I say slope, I mean m,
Yes.
right?
Yeah.
M equals slope, slope equals m.
Yeah.
Okay, And B, what is B? What is the word for B? It's a fancy word.
Intercept.
That's right, intercepts. Yeah, the y-intercept. Good job. Yeah. So it's the slope and the y-intercept. Okay. So same thing. Y equals mx plus b. And now we have, this is x and this is y. So y is minus 4 equals, we have 2 for m.
2 times minus 1
It's minus 1 plus b.
plus b.
Alright, we have only b, we solve for b. So minus 4. What is 2 times minus 1? Minus 2 plus b. Okay, how do we get rid of the 2? You want b by itself.
Plus 2
We add 2, that's right. Add 2 to both sides. Minus 4 plus 2?
minus 2
Minus 2
plus b.
equals b. Or b equals minus 2. Okay, and now we put it back. Right? We have y. What is m?
M is 2.
M is 2.
2x.
X. And what is b?
b is 2.
Plus minus 2 is minus 2.
Minus 2.
Right? Minus 2. Yeah, that's our equation. And again, you can check it. You can put these points in and you'll see it's correct. Any questions on this?
Yes, very clear.
Yeah, it's a formula. Once you know how to use it, you can use it. And the thing is, they give you this formula. So you don't need to worry. Personally, you should learn this formula. But if you're worried, oh no, if it's making you afraid, I'll forget. You cannot stress. You can learn the formula, but don't stress about whether you learned it, because they'll give it to you and you know how to use it. The most important is knowing how to use the formula. And this is in real life too, because in engineering and in physics, almost all the formulas I learned in university, I don't remember them. But it's easy. I can go on my phone. What is the formula for something? It shows me the formula. That's great. And now I know the formula. But if I don't know how to use it, my phone can't help me. Right? So that's why you learn here how to use the formula, and then you can get it from your formula sheet, from your phone, from whatever. But the math is knowing how to use the formula. Okay, any questions on this? Let's go on to the next type. I'll take a picture first. There we go.
Number 3.
You want to do number 3? Okay, I'll do number 3. That's fine. Number 3, we have minus 4, 2, and what is our slope?
Minus 1 over 3.
Minus 1 over 3, it's a fraction slope.
Yeah.
You know what though? You guys know how to do fractions, right? We learned fractions in the beginning.
Yeah.
Don't be afraid. Right? If you're running and you come to a hill, do you stop running? No, you lean in. Keep to going. Okay, so it's a fraction. Everything else is the same.
Yeah.
We just do everything the same. Okay? So y equals mx plus b, right? And now we have, here is x and here's y, right?
Yes, 2.
So 2, and what is m?
M is minus 1 over 3.
Let's put it in brackets just so we know
Yes.
everything, right? Just if I started in brackets,
Yes.
because that way I can make sure I'm doing the right thing.
Yes. Times minus
Okay,
4.
times minus 4
Yes.
plus b. All right. Right, so we're going to solve for b. We're going to keep 2. Now what is minus 1 over 3 times minus 4? We can write this here.
4 over 3.
Let's keep it as a fraction. In fact, most of the times in our algebra formulas, we keep things as fractions.
Yeah. 4.
Today we're going to learn something called a function, and we'll do functions further. And functions tend to be more like financial, and they'll often have decimals. But in when we're doing more pure algebra, they tend to keep them as fractions. Either way is fine, but part of the reason I like to keep it as fractions is because when we're doing multiplying and stuff to get rid of numbers, it's helpful to have the 3 here so I know I'm multiplying by 3. But if it's as a decimal, I don't know necessarily what to multiply it by to make it into 1. Or it's sometimes a bit harder. Yeah, I mean, if you have a calculator, it'll do it for you, but I think, let's do it like this. So we have the minus and the minus cancel each other out,
Yes.
right? And this is basically, it's the same as if it was 4 over 1,
Yeah.
right? So when we multiply, there's no crossing out, because these are the same numbers, and there's no common denominator, right?
Yeah.
So then we just do the top, 1 times 4 is 4, and 3 times 1 is 3. So it becomes 4 over 3.
Yes.
Alright, we leave it. 2 equals 4 over 3 plus b. Okay. Now we want to get rid of this 4 over 3 on this side, right?
You multiply by 3.
Um,
All of them.
No. Because we have b is all by itself. And b doesn't have any coefficients, right?
Yeah.
So the same way we did before, we added or subtracted whatever this was to get it onto the other side.
Okay, as we add 4 over 3.
So we subtract
No, subtract 4 over 3.
4 over 3 from both sides. Okay? So here 4 over 3 minus 4 over 3 will become 0.
Yeah.
And then the other one we need to do the problem, okay?
Yes.
There's 2 minus 4 over 3.
Equals
So here you have to remember your fractions,
Yes.
alright? How would I solve this? This is good practice.
This one 3.
So it'll become 2 over 1
Yes,
minus 4 over 3. We start there. Anytime you have a whole number, you can write as a fraction over 1. Right?
Yeah.
Okay, and now when we're doing adding and subtracting, remember you need to find a common
Yes.
denominator.
3.
So here it's 3. This is 1.
Yes.
So it'll be 3. So it becomes something over 3
Yeah.
minus 4 over 3.
6 over
6 over 3, exactly. And then the denominator stays on the bottom, 3. And we just do adding or subtracting whatever these two numbers are.
10 over
So
3.
6 minus 4 is 2. There we go, 2 over 3.
Yes.
So we get 2 over 3 equals, these cancel,
Yeah,
b. Alright, you see that? Or the inverse, b equals 2 over 3. And now the same thing, we put it all back into the equation.
Yeah.
Alright? So here we have y equals mx plus b. So that means we have y. What is m?
M is minus 1 over 3.
Minus
and
1 over 3, they give it to us.
X
Plus
2 over 3.
plus 2 over 3. That's our equation.
Yeah.
It probably also could be written, we multiply this by 3. So probably the same as 3y equals negative x plus 2. Right?
Yes.
Because I just multiplied everything by 3.
Yeah.
But this is the one we want. I won't do that. I won't confuse you with this. Because we want it in the format of y by itself. And actually you'll find out this is very useful today when we do two equations to find out where they intersect. You want to get y by itself. So one way that you can think about this is we started out with y equals minus 3x plus b, right? Because we have the slope. And then we substitute the points in here to find b. Okay? Come in. Welcome. Any questions on this? It was the same method. It was just more difficult because it was a fraction. But if you remember, you're multiplying a fraction and you're subtracting subtractions, you can do it. I'll take a picture. Alright. There's a picture, so if you want to keep writing it down, you can look at your phone. That's why I take them, because I want you, I know sometimes it's not a bad thing to like write. It helps remember things. But I also, yeah, but also I don't want to spend a lot of time while everyone's writing down. So I give it to you on the phone so you can write down if you need a copy of it. Alright, so let's do number 4, the next one. And now they want us to use the second formula. Okay? And if you see in the second formula, they don't give us b. Right? The second formula is kind of a shortcut. Because basically it says you can write it like this. You can write this formula here. and then you use the points as x1, x2. No, sorry, y1.
Y minus
x1, y1.
Yes.
You substitute them in, and then solving all of this back into this format, you'll have b on the end.
Yes.
So you'll get the formula. So it's kind of like, this one was a two-step formula, right? We solved for b and then we put it back. This one is one step. We put that formula in, we plug the numbers in, and then you simplify it and you get the formula. Alright, but the difficulty with this one is you're going to be working with unknowns. You're going to keep your x and your y, not the x1 and the y1, but the x and the y, will stay x and y. So when you move them around and you multiply by them, you have to keep them as x and y. So that's one of the challenges with that formula. So let's try it. Let's see. We have, what's the point? 2 and 1.
1, 1.
And what is this note?
It's got 3.
3. Okay. So now let's use this formula. So y minus y1 equals m bracket x minus x1. Okay. Now,
-1.
what we do is we substitute these things in, right?
Yeah.
So this is x1 and this is y1. So y minus
-1
1
equals
equals m is 3, x minus
2.
2.
Yes.
Alright, so there we substituted in. And now we simplify it until we have the format of y by itself on one side. Okay? So first we're going to need to do, and you have to remember PEMDAS,
Yes.
right? So first we'll do the brackets,
Yes.
right? 3 multiplying into here.
Yes.
Keep y minus 1 on that side.
3x
3x
minus 6.
minus 6. Okay. Now we want y by itself.
We are
So what do we do?
We at 1.
Yeah?
Is
So
equals to
we want to get rid of this minus 1.
minus 1 to plus 1.
Plus
6
That's
one.
right.
plus 1.
We do a plus 1 on each side. That's right.
Yeah.
So now we have y by itself.
Equals
3x. And what is negative 6 plus 1?
minus
Minus
5.
5.
Minus 5. You see the, actually you have the formula.
Yes.
Done. So in this formula, m is 3 like we said, and b is minus 5. But we don't even need to worry about b because we already have it written out.
And this one is the easiest.
It is if you know how to use it. It looks a bit scary, right? You see this, you're like, whoa, what's all these x's and stuff? But once you actually know how to use it, it's very quick. Yeah. Now I want to show you.
Yeah, I want to know also how do you look it from minus 2 to 1? Which one is x and which one is
Always A, B, C, D, X,
Okay.
Y.
Okay. X.
Remember? So
Mhm.
always the first one is
The
X,
first one is x.
always the second one is Y.
Okay.
And this is
Oh.
X1 and Y1. This is a specific point.
Okay.
So the X and the Y, the one without the little 1, right? The X and the Y here, we leave. Because we're trying to write the formula in terms of those.
Yes.
So we don't need to know what these are.
Okay.
Instead, we're substituting in each of these points. Now let me show you, let me prove something to you. Okay? Say we have this formula, y equals mx plus b. Right? So that means that, let's see, can I do this?
I think that's one okay, but the second one.
Pardon?
This okay.
This is okay? Yeah.
Yeah, that's okay.
So, I'm trying to think how to show you. Basically, yeah, it's kind of difficult.
And I got it.
You got it?
I got it.
Any questions?
I got
We
it.
can move forward if you're okay.
I
Yeah?
got it.
Alright. Let's do another one. I'm not going to do all of them. So let's do number 6. Or do you want, let's do number 5 because it has a fraction in it. Right?
Good.
Okay, so what is the point?
2 and 0.
2, 0. Oh, that's nice.
Yes. M equal minus 6.
Minus 1 over 3.
Yes, 1
Alright, whenever you have a 0, it's great.
Yeah.
Right? 0 make things easy.
Yeah.
So let's write it again. Y minus y1
Yeah.
equals m times x minus x1.
1.
Okay? Now on the test, I don't think they're going to care which one you use. So you can kind of use either one. Because
Because
you're getting like a point and a slope
Yeah.
either way. So you can use whichever one you're comfortable with.
Yeah.
But it's good to know both of them. I don't see how they would differentiate how you solved it as long as you have the answer, right? Okay. So what is y? Here's x and here's y. So what is y1?
Oh, I want 0.
0.
All right. So y minus 0. That makes it so much easier. What is m?
Minus 1/3
Negative 1 over 3 times
times
x minus
0.
2.
Minus 2, sorry.
Yeah, x is 0.
Yeah.
Okay, so y minus 0, nice.
Yeah.
Becomes y. And here, what's minus 1 over 3 times x?
Minus 1 over 3x
Minus 1 over 3x. And then
times
minus 1 over 3 times minus 2.
2 over 3
2 over
plus
3.
2 over 3.
Plus 2 over 3. Oh, that was the same formula as number 3,
Exactly.
right?
Yeah.
Alright. Was it the same problem? No, they gave a different point on the same line.
Yeah.
Alright. Do you see how I did this? It's fairly straightforward, I think. But I'm happy to answer questions if you have them, because if it's not making sense to you, we need to make sure you understand it.
This is good.
Yeah?
You can go.
Yeah.
Go
Okay. I'll take a picture of it, and then they give the two points. Did I take a picture? Oh no. There we go. Okay. So next, now they're giving you 2 points. Okay? So let's say number 7. You have, what are the 2 points?
Number 7.
Two.
Same page.
Minus 5 and
0,
3.
bracket,
What's the other point?
1,
1 and 1. This is actually the most common format you would get. Because you can, like, basically if you have a line on a graph, you can find 2 points on it, and you would look for the solution for it using 2 points. And this is great. Any 2 points, you can find the formula for it. Any 2 points. And what we have to do is we have a problem, right? We don't have the slope. Because all the equations, these 2 equations, rely on us having the slope. But fortunately, do you remember the formula to find the slope? What is the formula to find the slope? M
Y.
Y1
y2 minus y1
over
over
x2
x2 minus x1.
x1.
Exactly. And what we have here is x1, y1, x2, y2. Right? So we can do it. We find the slope, and then we use the equations. It's a two-step question.
Yes.
Alright, so first let's find the slope. M equals y2 minus y1 over x2 minus x1. So what is y2?
y2 5.
We can
This is 1. It doesn't matter. It actually doesn't matter. You can choose either one. Just make sure you choose the same for the x.
Yes.
Right? If you say this is 1, then both this and this must be 1.
The second one is yes. Good.
I'm going to say this is 1 and this is 2.
Okay.
Doesn't
I
matter.
did it if white is by
No
1, but I
problem.
didn't get the answer.
Okay. Well,
It's
let's.
changed with the negative and positive, the
Yes,
side.
Yeah. So that's fine.
Minus 4
Exactly.
minus 4 over 2.
Yeah. So let's just go through. Okay. So m y2 let's say is 1
Yeah.
minus
Minus
3 over x2 is
1
1. Remember, because if you choose this as your 2,
Yes.
this is also your 2.
minus
And put it in brackets. Minus 5. This is the key. Okay, if you have a negative number here and you're subtracting it, it needs to be in
Yeah.
brackets, so the sign
Yeah.
will go right. Okay, and that equals, what's 1 minus 3?
Minus 2.
3
Minus
over-
2 on the
over
top.
6.
And 1, this is negative 5, and plus.
6.
So it becomes minus 2 over 6.
Yes.
And
No.
1 over,
Yes.
1 over
minus 1 over
minus
3.
1 over 3.
Alright, so now we have our m.
Mm.
Now we can choose either of these 2 formulas. Who wants to do this formula? Put up your hand.
Yeah.
Ask one too.
Yeah.
Who wants to do this formula? Put up your hand. We can do both.
Yeah.
We can do both. Alright. So let's do the first one.
Okay.
Y equals mx plus b.
Plus
Now we have m, and now we can choose either point.
Yes.
Okay, it doesn't matter because they're both on the line.
Yeah.
So I'm going to choose this one because this looks like an easier point to use.
Okay.
Alright, 1, 1. I could choose minus 5 and 3, but you know, I think that 1, 1 is easier. Okay, so y is 1,
Yeah.
and our m is negative 1 over
Negative
3
1 over 3
times 1
times 1
plus b. Okay, so now we have 1. This is just
minus
itself,
1 over 3
plus
b.
b. Now we want b by itself.
We
Right.
add 1 over
Minus
3.
1.
So we add 1 over 3,
Yes.
because this will cancel.
Yes.
You were saying minus 1?
Oh, I said
No.
minus 1, but plus
Good, we now put the 1 on this side. We want the b is already
Yeah,
here.
we-
So we want the b by itself, so we want to put the numbers on the other side.
alright.
You're right, if you wanted to get rid of this 1, you would subtract 1. But then you'd have this equals 0, and you still have a problem.
Yeah.
If you want to get
we have
b.
to add
Yeah, so we add 1 over 3.
Twice.
1 over 3.
Yeah. Alright, so what is 1 plus 1 over 3?
Is 3. No, it's 1. 3 over
4 over 3.
That's right, it's 4 over 3.
4
So
over
we do
3.
3 over 3 plus 1 over 3.
Yes, 4 over 3.
Okay, because 1 is any number of itself, and we want to get this. So then that becomes 3 plus 1 is 4
Over
over
3.
3. Another way you can see is 1 over 3 is the same as 1 and a third. Remember, and we do this 1 times 3 plus 1.
Yes, yes.
So it's 4 over 3. Okay, so here we have 4 over 3
Equal B.
equals b. Alright, so now we have m, and now we have b.
Yes.
So we just substitute. Y equals minus 1 over 3
Yeah.
plus 4 over 3. I won't do it the other way, but if you want, you can go home and try it. You'll see it'll be the same. Oh, x. 1 over 3x plus 4 over 3. I'll put a box around it.
Yes.
Any questions on that?
Give me different result, not minus 2 over 6.
You didn't get minus 2 over 6 here?
No.
No,
No,
might
it's-
have.
I did 3 minus 1
3 minus 1, okay.
over 5 minus 5 minus 1.
So 3 minus 1 is 2.
Yeah,
And minus 5 minus 1 is
Minus
minus
4.
6.
minus 6.
It's minus 5 minus
6, yeah,
1.
minus 6.
So then you get 2 over minus 6,
Yes.
which will still be negative, and 1 over 3. So I think you made a mistake here,
Yeah.
when you subtracted 1 from minus 5.
We didn't minus 5.
No, you have it here, 2 over 6. This should be a minus 6. It's minus 5 minus 1.
Okay.
Be minus 6,
Yeah.
yeah. Small mistake. It happens all the time, I make them too.
But the mistake is mistake always. Whether it is
Yes, but this is, now is the time we practice,
Yeah.
right?
Yeah.
We figure out what we did wrong, more practice, less mistakes. You want to make no mistakes, but you want to make less mistakes.
Sometimes when we go fast, a lot of mistakes.
Yes, it's true. It's true. Alright, you want me to do another one like this?
Ah,
Okay.
yes, yes.
I'll do another one with 2 points. I'm going to expand our box.
That mistake in some previous question.
Pardon?
The mistakes, on the previous question because it is easy.
Often you do.
Yeah.
Do you want to do 8 or 9? Which one? I'm going to do one of them.
9.
It's okay.
9?
just one.
Okay, we'll do 9. So 9, what are our 2 points?
Minus 3,
Minus
4.
3, minus 4,
7, 1.
7, and 1. Okay, minus 3, minus 4, and 7, and 1. We sure?
Yes.
Yeah.
Yeah. Okay, so the same thing. We first need to find the slope. Right? y2 minus y1
1
over
over
x2 minus
Minus
x1.
x1.
Okay. So,
You can say 7
What is y2?
or 1.
We'll do this one as 2.
Yes.
Yeah. So 1 minus
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 4.
Negative 4.
minus 4. Remember, it's minus minus.
Yes.
And the x2 is 7
Minus 3.
minus 3. Alright. So that's going to be 1 plus 4
Yeah.
over 7 plus 3.
3, yes.
Right? Which equals 5 over 10.
Half.
Which is 1 over 2. Yeah, half. Okay, so m is 1 over 2.
1 over 10.
Alright. This time I'm going to solve it with this one.
Yes, okay.
Okay?
Yeah.
Just to mix it up a little bit.
Yeah,
Okay.
good.
So we have y minus y1 equals m
M
times x minus
minus
x1. Yeah. So we can choose either point. I'm going to choose this one because it has less negatives in it.
Okay.
Doesn't really matter.
It's good if you choose the most, because where a lot of negative people used to.
I mean, if we choose negatives, they're going to become positives.
Choose one.
I would just advise always choose the one with less negatives.
Okay, good.
Because you track. But if you want practice, it's fine. It doesn't matter either way. Y minus, what is it? 1?
1.
What's our slope? 1 over 2?
1 over 3. X minus
7.
Okay. So we'll keep this side. We'll solve that later. What's 1 over 2 times x?
Half x
1 over 2x, half x. And what's 1 over 2 times negative 7?
minus 7 over 2.
Minus 7 over 2. Okay? And now we want y by itself, right? So how do we get rid of the 1 now? The minus 1.
We add 1.
Do you agree? We add 1.
Yeah.
Okay, so y, sorry, let's just write that. So we put plus 1 and plus 1 here. Okay, so now we have y equals 1 over 2x. Let's see this one, okay?
Yeah.
So let's do minus 7 over 2 plus 1.
Plus 1.
Okay? Remember, 1 can always be written as the same number over itself.
Yeah.
And since we wanted 2, we should do 2 over 2.
Yeah.
So it becomes minus 7 over 2
Yeah.
plus 2
2
over 2.
2.
Okay? Now we have a common denominator and we add these. So what's minus 7 plus 2?
Minus 7, minus 5 over
5.
2.
Minus 5, right? So that equals minus 5
over 2.
over 2. Alright? Minus 5 over 2. That's our answer. Don't be afraid of fractions. Okay? You will have fractions in these things. Write that a bit better.
Good.
The fraction slope just means it's more flat,
Yeah.
right? Like this is steep, fraction is more gentle. Any questions on this? No? Alright, let's take a picture. You can look at some of these other. Okay, so number 10 is the same, right? It says which of the following, except for something like number 10, you can just substitute them in, right?
Yes.
But the problem is one of them, the line might have one of the points in it, but not the other point. So that could be, you don't want to, if you want to do substitution, you have to do two in each. What I would do for, here we'll do number 10, because it's good practice. Number 10 says we have minus 1, 0,
Yeah.
and
2 minus 3.
2
Minus 3.
minus 3. Now, we need to find the slope, right?
Yes.
So let's do the slope. y2 minus y1 over x2 minus x1. Okay. What is y2?
Yeah, minus 3.
Negative 3. What is y1?
0.
0. Okay, what is x2?
2. Minus 1.
Minus 1. Okay, so here we have negative 3 over 2 plus 1. Right? These
Yeah.
cancel.
Over 3.
So this becomes negative
Minus 1.
3 over 3, which equals minus 1. Alright, now before we substitute back in here, we can stop. Alright? And look at our options. What is the slope for A?
C.
Do you see that?
Yeah.
A is y equals 3x plus 3. So that means I know m is 3 in that one. Right? Here our m is 1. So which one of these has an m of minus 1? Sorry, m is minus 1.
C.
C. And only C.
Yes.
So you can stop.
Yes.
You see that? That's why I wanted to do this question. You don't actually have to go all the way through.
Yeah.
When it has, I looked at these options and I saw they all had different slopes. So then I understood all I need to do is solve the slope,
Yeah.
and whichever one has the correct slope is the correct answer. Like, this is a very powerful formula. Because what this formula says is you can look at any formula and you instantly know key features of the line. You instantly know the slope. So I know this one's going down, and it's going down like as much as it goes along, right? And I instantly know it crosses the y-axis at this, whatever b is. So you can instantly know things about the formula, about the line, just by looking at the formula when it's written in this way. So here I knew we just have to solve for m, and we can find whichever one has m. So C, only C has m equal minus 1. Okay, so it's obviously C. Let's do number 11. That looks like it could be confusing. It says, which of the following is an equation for the line that passes through minus 3, 4,
4.
and
1
1, 4. Okay. So in this case, we're going to have a problem. And even if you look at the options, right? We have 3 options. We have 4 options here. So let's start with our m. We have 4, right?
Yes.
Minus
Minus 4.
minus 4 over
1.
1
Minus 3.
minus minus 3. What is 4 minus 4?
0.
0 over
Over
4,
4.
which equals 0. So
Zero.
that means m is 0.
0.
Okay, so that means the equation is just going to be y equals b. Right? So when you see something like that, so it means y equals b. Right? When we see something like this, it means that the equation is the form of a line, a straight line. When the slope is 0, it means it's not going up at all.
Yeah.
Or up or down, it's going flat. So it's a flat line, and it crosses y at some point. But what this means, when you see something like this, is whatever the y is in one point, the y is in the other point. Which means it's y equals that number.
Yes.
That's what the formula will be. So this is 4, right?
Yeah.
So it must be y equals 4. Because it's going through 4 the whole time. Now if you're unsure, we can keep going with here. We have 0, and then we substitute one of these in, right? We can say y equals mx. I'll just put a little dash around here. Let's add dash. Okay. Y equals mx
That's B.
plus b. Okay? And now we can substitute in. So here we have 4 equals 0 times either one,
Yeah.
actually,
1,
plus b.
yes.
So then 4 equals b. So y equals 4. Because it's y equals 0x plus 4. And 0 is going to be 0, so it's just y equals 4. So that's strange. It doesn't look like a formula, does it? But it actually is.
Yeah.
It's a formula where y equals 0. And if it's this type of line, goes down where where x is always the same, is actually an undefined, because we have an infinite slope. Right? The slope goes straight up,
So,
so it's an infinite slope. So we just say it's an undefined equation. Or you could say x equals something. But the problem is we always want to write our formula in terms of y equals something. So we can't write it y equals something because y is, there is no y. Right? It never crosses y. Y can be any number. Y can be anything. So you could say x equals something, or you say it's an infinite slope if it's a line like this. But like this is a y equals just the number. The number that it crosses here is the y equals. Any questions on this one? Okay. And yeah, you can kind of, even if you just look at these 2 points, you can see the y here is 4 and y here is 4, which means y is not changing.
yeah.
And if there's no change in y, there's no rise, there's no increase. So the slope is 0. Alright, and then let's go. So number 12, you would just solve it out. It's already written off for you. But let's just look at number 13. I think we can just look at it. No, I'll draw it. I'll draw it out. Ahmad, do you have your ruler today?
Yeah?
May I borrow it, please?
Yes.
Thank you. Thank you, sir. All right. Let's just draw out here. Okay.
It's not a problem.
I think it'll come up.
It's
Just have to-
not a problem.
Maybe I shouldn't be borrowing you.
No, no, no. Sexy.
Alright.
Yes, another one.
Yeah, it comes up. You just have to kind of
Two.
work at it. Alright. I won't keep using it. Anyway, so we have here, it goes through, here is -1, -2, -3, -4, -5, -1, -2, -4, -5, and this is 1, no. 1, 2, 3, 4, 5, 1, 2, 4. Okay, and it looks like it's going like this, I think. Is the line?
Yes. 4, -4, -4.
Yeah, so here's our line. And it says, which of the following equations correctly describes the line on the graph? Now what you can look at, this is an important skill. If you look at this line, the first thing we should see is where does it cross the y-axis, right? So at what number does it cross? This is y.
X, x0, x0 and 0 -4.
0 and -4, right?
Yes.
So this point here is 0, -4.
-4, yes.
And what's this point here? We see as well.
-4, 0.
-4, 0. Alright, so using these 2 points, we could calculate the line, right? We find the slope, then we use the formula.
Yeah.
But, and let's do that actually. Well, no, first I'm going to show you, before we do that, we can actually find the line without doing that. And that is, the point where it crosses the y-axis is the y-intercept, right? B is the y-intercept.
Yes.
Do you know what it means to intercept something? Right? If I were to throw this back to Ahmad,
Yeah.
and Ahmad puts his hand up and grabs it, he intercepts,
Interesting.
right? It's a term they use in games, right? If someone kicks the ball to their player, and the other player comes and grabs it and goes, he intercepted the ball, right? So here, the line, where does it intercept the y-axis? Right? It crosses the point where it crosses the y-axis. So if b is the y-intercept, here is minus 4. So therefore we know b equals minus 4. Okay? So that's the point where it crosses the y-axis. Is our y-intercept. So the other thing that we need to not find slope. And slope is rise over run.
Yes.
Okay? So as we go this way, it's going down. So a downward slope is positive or negative?
Negative.
Negative. Alright, so we know slope is negative. And we start here at 4, minus 4, right? We go 1, 2, 3, 4 across. And we go down 1, 2, 3, 4. So our rise is minus 4 over 4. Right? So our slope is 1. And if we have a b and we have an m, we have an equation. So y equals negative 1, negative x, minus 4. So you can learn all this just by reading the graph. Right? And this is something that's important. If you see a slope that looks like the same amount as it goes across, it goes down, it has a slope of 1. Right? If it goes down twice as quickly as it goes up, or as it goes across, it's a slope of 2, minus 2. If it's like half, it's a slope of half. So that's what slope means. It's basically how quickly does it go down or up. So here we have this. The other ways we can use this to do the formula. So if you want to do it with the formula, I'll show you. We have these 2 points.
Yeah.
So m equals y2 minus y1 for x2 minus x1. So y, let's make
Yeah. This one.
this one, we only need 2 or 1? 2. Alright, this is 2. So it's negative 4
Negative 4.
minus 0
0.
over,
Negative 4.
over, this is
Over
the 2,
zero.
right? So we have to keep it consistent.
Zero.
This is our 2
Minus
minus,
4.
minus 4. Okay? So that's negative 4
Yes.
over
Over
4. Because it's minus minus
Minus
is
1.
4. So that equals
Minus
minus 1.
1.
So m is minus 1, just like I said over here.
Yeah.
Okay? And then we substitute it back in. We can do either one of these formulas, right?
Yeah.
We'll do mx plus b, why not? No, let's do the other one.
Y1 minus Y1.
So y minus y1 equals mx minus x1. Okay. And we can use either point,
Yeah.
right? So let's use this point. So y minus 0
Minus 0.
Right?
Yes.
equals negative 1
Yes.
times x minus minus 4.
Yes.
Right? You guys agree with that?
Yes.
Okay. So then this becomes y. That's why I chose this point, by the way,
Yes.
so I can just get a 0. And that equals negative x.
Yes.
So this is plus 4
Negative 4.
minus 4. This becomes plus 4 and the minus becomes negative 4. Which is the same thing we got there.
Okay.
Okay? So that's the longer way to do it. Or you can do it this way. Any questions on that? This is number 13, by the way. Alright, let's go on to the next page, which was on page 374. And this was basically using slope to do some word problems. So we're basically using the slope formula all over again. So let's look at some of these. 4. Okay. So it says use the slope formula to find the rates that correspond to the numbers in these scenarios. Let's just look at number 1. It says a catering company orders 150 pounds of fresh clams for a banquet serving 100 people. and 30 pounds of clams for a dinner party of 20 people. Determine the standard number of clams per serving. So we have 150 pounds for 100 people and 30 pounds for 20 people. See, basically you say, let's see, the rate is, we want it in pounds per people, right? No, number of clams per serving. Yeah. So we want this to be the top and this to be the bottom. So we'll say this is kind of like y 2 equals 150 pounds, okay? And x2 equals 100 people. Alright? It's important, what we choose to be our y is what's going to be on top. Right? So it says it wants how many clams per people. It means people needs to be on the bottom. So people needs to be our x. So what we do is the same formula, right? And we just do it. This is y2, right? So 150 minus 30 over 100 minus 20. Okay. What is 150 minus 30? 120. What is 100 minus 20? 80. Alright. Can we simplify this? Okay, so first we can cross out the zeros, right? And then we have a common 4, I think I heard?
3 over.
Yeah, so 4 goes into 8 2 times, and 12 3 times. So it's 3 over 2. Alright, that's our slope. And now that's actually our clams per serving. So it's 3 over 2 pounds per, I said people, but I guess it's serving. Clams per person. The key thing here is to make sure that your y is the one that's the first thing that's asked for, right? So it's asking for how many clams per serving. So then we're going to do pounds of clams on top as our y. Let's try the next one. Honestly though, I find this kind of a question a bit strange. They're trying to use the slope formula and we're doing it. But really we could just get the same thing from one of them because it's a consistent line, it's a straight line. So we could just say we want to know pounds to people. We just do 150 to 30, which equals 150 over, no, 150, sorry, to 100. 150 to 100, right? 150 over 100, and you'll find that that also equals 3 over 2. So I feel that there's actually an easier way to do these problems that's not using the slope. But I think they're wanting you to do it so you can learn how the slope formula can be practically used. Because in the future you will not be having, you won't have straight lines. Right? The kind of lines you have will be lines that do like this. Alright? And so they'll have, to get the formula for them, it'll be some kind of like y equals 1 over 2 x squared minus 2. Something like that. And then you have to kind of do both pieces to solve it. That sort of thing. Or more work to figure it out. So that's why they are teaching you this at this basic level. At this sort of like beginning level for kind of more university level maths in the future. So let's do number 2. This is number 1. Okay. Just to practice it. A painter uses 15 gallons of interior paint to cover 300 square yards of wall and ceiling. On a different job, he uses 8 gallons to cover 160 square yards. No paint is left over on either job. How many gallons of paint are needed to cover 1 square yard? Okay, so we need to see it's essentially
The same thing.
the same thing, right? Yeah.
Yes. 15 covers 300.
10 gallons.
So we have 15 over 300, right? Equals what? 1 over 8, you said? 1 over 20, I think. Right? 1 over 20. So that means 1 gallon will do 20 square yards. Yards? Yeah. Yard square. Okay? But we want to know how much is needed for 1 square yard, right? So, if this is 1, what is this one? So we have 1 over 20 equals unknown over 1. Right? So we can put a x here. No, that's not right.
Maybe square root of 20.
So what we need to do is we need to basically get 1 gallon will do 20 yards. So I guess we just find this as a fraction, right?
Yeah.
So what's 1 over 20 as a
Other fraction.
actually this does work. This works.
0.05.
This is correct. 0.05 gallons per square yard. Yeah. So actually 1 over 20 is the correct answer. Yeah, because it means if we just divide this out, it means one gallon will do 20 yards. If we one yard, we need 1 over 20 gallons, right?
Yeah.
Because if we have 20 of 1 over 20, we'll get 1. So we just need 1 over 20, or 0.05. So either answer is correct. I was making it too complicated. I already had the answer.
Yes.
Right?
Seems like
Yeah, 1 over 20 was correct.
What about the second point? Is 8 over 160.
We can check it. 8 over 160 also equals 1 over 20. Now they're wanting you to use the point slope formula, right? Alright, so what they want you to say is, alright, m equals y2 minus y1 over x2 minus x1, which equals 15 minus 8 over 300 minus 160, right? Which equals 7 over 140, which equals 1 over 20 still. Okay? So what I'm just... Yes, this is in the slope formula, but these kind of problems you can solve just with the... I find it a little bit strange that they're making you do all this extra work when really you can just solve it with the one ratio.
Through this extra work, we will do that one. But there, we will not be able to do this.
Yeah,
So what is the benefit?
that's alright. Okay, if you want to graph it, like number 4, you'd have to do that. But I think it's time for a break. So let's take a 5-minute break. So let's keep going through the review on this page. So let's look at numbers 4 and 5. You see they've got this chart. So let's do number 5. I'm not going to keep using Ahmed's ruler because the marker is ruining it. So hopefully you can just draw straight lines using the grid. Alright, and it has like a bunch of right? And then cross kind of like this. Okay. So it says a vintage vinyl record player spins at a rate of 78 RPM. RPM means revolutions per minute. Oh, it says it there. Draw a graph of the number of revolutions, y, per time x. Plotting points for 3 minutes, 4 minute, and 5 minute record. Okay, so what this is saying is, essentially, we're going to start at 0, 0. Okay, so the graph is basically y equals 78x. Okay? Because we start, this is sort of the easiest for most of these problems. We just say y equals whatever our rate is times x. Okay? And we need to draw it. So this is 0, 0, right? And this is 1, 2, 3, 4, 5, 6. Okay? So we'll make this one 3, then 3, 4, and 5. So let's say we have to put the numbers in, right? So let's do like 50 and 100, I think. 150, 200. It's kind of like that graphing section earlier in the course. Do you remember? Remember like graphing, plotting things on a line? So that means at 1, it's going to be 78 revolutions per minute, right? Because it says it's 78 revolutions per minute. 1 minute is 78. 2 is 78 times 2, right?
Yes.
So at 3, what will it be?
78 times 3.
78. What is 78 times 3?
24.
234.
Yes.
Yes, you're right. 234.
Yes.
So we go up. I made these two. I made them two not big enough. Let's make them hundreds. Okay? 100, 200, 300, 400, 500, 600, 700. Okay, so 3 is 234. So here's 200. 34 is like just above, right? So we plot it here. Okay. 4 is 78 times 4, right? That's a 2.
32.
Carry a 3.
28.
28 plus 3,
31.
31. Right? Okay. So 312. So kind of like here. Okay. And then 5, 78 times 5, 0 and a 4,
390.
390. Alright, so here, like that. Okay, and you draw a line through it to 0. That's the answer. And you're basically just plotting it. They seem more complex because it's like a lot of words. But if you look at the math of it, it's basically just saying you need to draw a graph of this thing. You don't even need to worry about this. You just know that it's the 78 revolutions per minute. And we have this is revolutions. And this is minutes. Right? Similar to what we did before. That's an O, by the way. And you plot. Do you remember when we did line graphs? We plotted them. It's the same idea. It's the same thing. Any questions on that? Then we do the inverse. Number 7. Number 7, we have a plot, right? Okay, and it has this whole description. I'm going to read it to you now, but I could probably figure out from the chart what we need to do. So it says 3 carpet installation jobs. The contractor records the values above with the goal of analyzing whether her rates are high enough given the time it takes her to install carpet. It takes her 1 hour to collect tools and drive to her work site. The x-axis shows square yards of carpet, and the y-axis shows hours spent. What is her rate of time per area installed? So it's a lot of stuff, right? But what we can look at is if you look at this chart, actually I'm going to use my current chart. We'll take a picture and then reuse it. I think that's easier. kind of explain what's happening. Yep. Put 7 over here. Number 7, it has these labels. It says hours over here, right? And carpets. Installed. Yards squared. Okay, square yards. And we have 0, and it's going up by 0.5, right? 1, 1.5, 2, 5, 3, 3.5, and on. And here it has 50, 100, 200, 150. It's going up in increments of 50. 200, 250, 300. Okay, and so it has 1.5 is 50 is here. It's kind of like here, right? And 100 is at 2.25. Here it says. And then all the way 300 it's 4.5. And 300 is all the way up at 4.75. So here. Okay. And it actually labels them for us, right? It says this one is 40, 1.5. This one is 100, 2.25. And this one is 300, 4.75. Okay. So what it's saying is, if you read here, it says it takes her 1 hour to collect tools and drive to her work site. So that's why if you see this line, right, if you were to draw a straight line here, it wouldn't go to 0, it goes to 1. Because that accounts for the extra time it takes her. She drives to the work site. It doesn't matter how much carpet she lays, she'll start at 1 hour. Okay? And what they want to know is what's the rate of time per area installed. So actually what they're looking for is a slope, right? So all we need to do is find the slope using these points.
2 points.
So we have 2 points, right? So there's this whole complex setup. We just need to find the slope. So you could get lost with all this stuff, right? But actually we have 3 points. We only need 2 and we can find the slope.
Yeah.
So let's use these 2 points, right? So it's got 40, 1.5, and 100, 2.25. Okay. And so then we have y2 is this one.
2.25.
Wait a second, is that how we want it? Yeah. Hours. 2.25 minus 1.5 over 100 minus 40. Okay. Let me do it this way. What's 2.25 minus 1.5?
1.10. Right?
No.
Let's just do this. This is 5. Cancel that's a 1. Carry it. 7. 0.
0.20.
Right? Does everyone agree with my subtraction?
What
Ah, 0.
is that?
Because you have to carry the 1 to get this.
Oh, yes.
Right?
Yes.
That becomes 7. So 0.75. So that equals 0.75 over 60.
Yeah.
Alright, we could probably use a calculator at this point. Does it say? It does not say, but we probably could use a calculator. However, if you want, I can solve this. It's a decimal over inside a fraction.
Yeah.
I don't like that. But if I wanted to solve it, I could say it's the same as 0.75 times 1 over 60. Okay? Right? So you can just say this times this will equal this. Just like this over 1. And 0.75 is the same as 3 over 4 times 1 over 60. Now this I can work with. Alright? We cancel this. That becomes 20. That becomes 1. So that equals 1 over 80. And then we might have to do like long division or calculator to figure out what 1 over 80 is.
It is.
Probably 0.37.
0.0125.
But honestly, you can just use your calculator.
Yeah.
Right?
Yeah.
And if you want, I'll do the long division. I know you guys like it when I do the long division. So
It's like 80.
we have 80.
Yeah.
1 divided by 80, right? That equals 0.0. So we have 0.0.
125.
1.0125.
Yes.
80. We get a 20 here,
Yeah.
right? Goes into this how many times? 2.
Yes.
160.
Yes.
We get a 4 here, another 0.
5.
Goes into that 5 times.
Yes. This is
400. 0. So it's 0.0125.
125.
Is that one of our options?
Yes.
It is.
Okay.
Okay. And you didn't have to do the long division. You could use a calculator.
Yeah.
But it's good practice. Good practice. You could just get to this point here, 0.75 over 60, and just use the calculator.
This one also.
Okay.
Do this.
I'll say, or use calculator equals 0.0125. Okay? Any questions on that? So it was like this complex setup, this very long description, but in the end you just needed to do the point slope formula. Take the picture. Did I fill it all? I think so. Yeah. Okay. I want to get on with our lesson for today. Let's say we have 2 lines, right? We have the line, line y equals 4x minus 4. And we also have the line y equals minus 2x minus 3. Now we can plot these lines, okay? And we can find out where they would fit on a graph. So this one, let's see. This one has minus 4, so 1, 2, 3, 4 is our y-intercept. And it's, for every 1 across, I go down 4. Right? 1, 2, 3, 4. So it's basically like a long 1, 2, 3, 4, like this. And this long line like that. Okay? That's this line. This one, -3, right?
Yeah.
And -2. So it means it goes, for 1 across, it goes 2 down. 2 down. Across 2. You can plot that like that. And you see there's a single point where they intersect. Right? They have a specific point that they intersect at. And what we're looking at is actually, there's a lesson, this is called a system of linear equations, because it's 2 lines together, so they make a system. And there's a way that we can do algebra to find out what is that point where these 2 lines intersect. Alright? So there's 3 ways we can do it. The first way is you just plot the line. Right? You plot the line and you read out what is this point. This point is a bit of a strange point. Right? It might be a fraction. It's not clear. It's not easy to read from these graphs what that point is. But there's 2 other ways we can do it. So this is, let me just give you some context. It's called, these are linear equations. Right? So it's an equation for a line. So that's why it's a linear equation. See the line, it's like saying a line art. Like it has to do with a line. Linear equation is equation. So it's equation for a line. And this is a system of linear equations. System just means many parts working together. Right? So because we have more than one, that together they're forming a system. And we want to find the intersection. The intersection of these 2 parts. So, what we can do, there's 2 ways you can do it. Okay? One is substitute. Substitute. And the other is add, subtract. Whole equation. Okay. So the reason we're doing this, the GED book that you have is only teaching you the substitute way, but I want to teach you the add subtract way as well. Okay? And what that's saying is, if we look at these 2 equations, it says y equals 4x minus 4, right? Y equals 2x minus 3. Both of these are y. So there's one point where they intersect, right? At that point where they intersect, they have the same y and the same x, right? So at the point where they intersect, y equals this, right? And y also equals this. So that means if we solve for y, we can put it in and say 4x minus 4 equals minus 2x minus 3. Right? We substitute y. Do you see that?
Yeah.
So you can, what you can do is sometimes it will have like 3y or y minus 2 or something. You solve it into the format of y by itself, and you put that in. Or you solve it in the format of x, and you substitute x in and solve for y. One way or another, you find one and you solve for the other one. So here we have now 4x minus 4 equals negative 2x minus 3. All right, we have one variable and an equation. We can solve it.
Yes.
Right? First it gets x's on this side, and y's on, and constants on this side.
Yes.
4x.
So let's first of all, we will add 4 to both sides. Okay? So now we have 4x equals minus 2x plus 1. Right? Now we want to get the x's on the same side. Okay?
Plus 2x.
Plus 2x.
X.
2x.
Yeah, that's right. We add 2x to each side. Alright, so now we have 6x equals 1. So x equals 1 over 6. I think I didn't choose my problem as well as I thought I did. Alright, it's going to be a bit more complicated because there's a fraction in it. We'll go through with it. So x equals 1 over 6. So that means we have x. Now we need to find y. Right? So because we said both of these are the same, we could put it into either one. So if we have x, let's take this one. Y equals minus 2x minus 3. We put x in. Y equals minus 2 is 1 over 6 minus 3. What is minus 2 times 1 over 6?
Minus 1 over 3.
Minus 1 over 3 minus 3. So y equals, you could just put these together and it would become minus 3 and 1 over 3. Or minus 10 over 3. If you want, I can add them as well. Right? Minus 1 over 3 minus 3 over 1 equals minus 1 over 3 minus 9 over 3. Right? Minus 1 minus 9 is minus 10.
Minus 10 over 3.
Okay, so there we have our points actually. It's 1 over 6 minus 10 over 6. So they're not very easy points. So if we look here, right, it's 1 over 6. Oh, so I didn't draw it properly. It probably should be here. Sorry,
Okay.
it should have been on this side, and then 10 over 6 would be like 3, 1, 2, 3, and a little bit down. So it would be like here. So I should have drawn them a little differently. But if I'd drawn them more accurately, the intersection point would have been at this point here. The other way you can do it is, I'll give you another example of one of these. Since mine is not as good as I thought it was, I'll use the one the book has, because that's more nice solution. You don't need to plot it. What you could do is the add and subtract method. Okay? And that one, let's say we have, oops. Six x plus 3y equals 12. And the other one is 5x plus y equals 7. Alright. Now, the add and subtract method is you subtract the whole equation from the other one. Alright? To do that, though, you want two of these numbers to be the same. So I'm going to multiply this whole thing by 3. Okay? So now I'm going to get this one equals 15x plus 3y equals 21. Okay? And now I have a 3y here and a 3y here. So let's write this one 6x plus 3y equals 12. And now what I do is I actually can subtract the entire thing. Okay? Because I know these will cancel. So 15x minus 6x is 9x. 3y minus 3y is 0. 21 minus 12 is 9. Do you see that? I multiplied this. I wanted to get one of them right. So I multiplied this by 3 so that they will be equal, and I subtract the whole thing.
How you get it this straight?
Now you may ask me, how on earth, Paul, are you allowed to do something like this? Right? Like where does this come from? So, pardon?
Skill.
Skill, yes. Remember what an equation is, right? An equation says whatever is on this side is the same as what's on this side, right? So that means whatever this is, 5x plus y, it equals 7. So if I multiply this by 3, I can also multiply this by 3,
Yes.
right? because whatever I do to one side will be the same to the other side. So I can multiply them by 3. Then, also, remember, whatever's on this side, if I do something to this side, I can do the same to the other side. Right? So here's the trick. That means I have this whole equation, and this side equals this side. Right? So if I subtract this side from here, I can subtract this one from here because these are equal. Right? This is A and this is A. So whatever I do to this side of the equation, I do the same to the other side of the equation. But I know this one is equal, so this, subtracting this from here, and this from here is subtracting the same thing from each side. I don't know if you see it, right? 6x plus 3y equals A. 12 equals A, right? Because they equal each other, right? So then what I'm doing is I'm saying 15x plus 3y minus A equals 21 minus A, right? Whatever I do to one side, I do to the other side. But I say A equals this and this because these two are equal from this equation. So that's why I can subtract wholesale the equations. It's a cool method.
Yeah, very cool.
It's not one that they teach you in the book, but Khan Academy teaches you, so I'm going to send it to you and you can read his thing as well. Or listen to his. But it works really nicely. So here we have x equals 1.
Yes.
Alright?
Divided by 9.
Divide
Right?
it.
Yeah, I divide each by 9. Right? And x equals 1. And then I can substitute that back in, right? Let's say this one. So 5 times 1 equals, no,
5 times 9.
x equals 1.
1, yeah.
Right? 5 times 1 equals, plus y equals 7, right? 5 plus y equals 7. Y equals minus 5 from each one. Y equals 2. So our problem is 1, 2 is our intersection. You can also do it the substitution method, right? If I wanted to do this with the substitution method, what I would do is I'd take this one, I'd say I have 5x plus y equals 7. Now I'm going to subtract 5x from each side, okay? And I get y equals negative 5x plus 7, right? And now I plug that in to the other one. So we have 6x plus 3y equals 12. And now I know what y equals, so I do 6x plus 3 times this, right? Minus 5x plus 7 equals 12. And now I solve for x. Now this is more complex, I think, or it's more steps. So let's do this first. 6x. Let me do it this way here. So what is 3 times minus 5?
Minus 15.
Minus 15x. What is 3 times 7?
Plus 21.
Plus 21 equals 12. Okay, what is 6x minus 15x?
Minus 9.
Minus 9x plus 21 equals 12. We need to subtract 21 from both sides. So now we have minus 9x equals, what's 12 minus 21? Minus 9. Does something look familiar here? Divide by minus 9.
Yes. X equals what?
X equals 1. We're back here. Okay? So this is the substitution method. You write the equation in terms of one of the variables, and you plug it in. You put it in to the equation. Yeah, in terms of, you put it into the second equation, yeah. If you put it back into the same equation, you're going to get 0 equals 0. Which is true, but won't help you. So you have to put it into the other equation. Okay, these are systems of 2 equations. We're going to practice this. I want you to practice this at home. We've got a bunch of problems, and we'll review it again next week. But first, I just want to ask the questions on what I've been doing here. So basically the goal here is to find the intersection point.
Teacher, how
Yes.
you bring from where you get the 3? You multiply.
This 3?
Yeah.
I solved this one, and I said I know in order to subtract them, I want them to be the same.
Oh, okay.
I could have multiplied through by 6 over 5, and then I'd get x is the same and subtract that. But that would be more complicated. So instead, I said I'll multiply this by 3, so that I'll have a 3y here. Because then when I subtract it, 3y minus 3y is 0. So that's why I multiplied this by 3. The whole thing by 3. But whatever you do to each one, you have to do all the way through. I'll send you the Khan Academy on where he explains it as well. It's a really good method. It's a cool trick.
Yeah, this is like in order to cancel the y, right?
Yeah, because I want to get rid of the y's.
It might be like 7, 8, no problem. Just we see the first y, which numbers.
Which number's in front of the y? Yeah, I do that. You could also do it the other way. Maybe x would have been easier. Then I'd do x and I'd solve for y.
Yeah, because
And then I'd put y back in.
there's no number like somewhere like
Yeah.
6x.
Pardon?
I mean like if you want to cancel like x, because there is no any number we can divide y.
Yeah, there is. If I want this to become a 6, I multiply it by 6 over 5. Right? It's a little bit difficult, because then I have to multiply everything by 6 over 5.
Exactly.
So then it would become 6x plus 6 over 5y
Yeah.
plus equals 42 over 5. Right?
If 5
And then I could do it, but
if
more
5 is
complex.
3,
Teacher,
you already-
if the
wait, let him finish, and then we can.
okay.
Yeah, sorry.
I mean like if 5 is 3, you already can like multiply by 3 and by 2 in order to get 6 to cancel the x, right?
You could do that. Yeah, if it was a 3, exactly. If this was a 3,
Yeah.
you multiply the thing by 2,
Then
and you could do it that way. Yeah, exactly. Yes, Marco.
So if the variable come equal,
Yes.
what I'm going to do?
If the variables are equal, what do you mean?
Like it come like 3y's and don't 3y again.
And 3y here?
Yes.
Then you don't have to do anything. You already have it ready to subtract.
Okay.
Yeah, that's a nice, easy one.
Yeah.
If it's 3y here and 3y here, then you just go straight to this stage. Yeah, you just subtract it through. I only did this to make it so that I could have 3y and 3y. Because this is the beauty of the equation. Because you can do anything to one side as long as you do it to the other side. That means you can change it to get it to look the way you want it to for your next step. And that's what's such a neat concept with an equation. Because they equal each other. So as long as you do the same thing to either side, you can multiply by 200. And it's fine, if it helps you. So here, it helped me to multiply by 3, because I wanted to get the 3y. And here I'm subtracting, and because I know this equals this, I can subtract this from this side and this from this side, because I'm actually doing the same thing to each side. Yeah. All right. I wanted to cover another item before we go. So let's do that. I want to move us forward to be finishing the course. Okay. And this is something called patterns. So if I write what's the next number? 15, right? That's you guys know why. Because we're doing 3 every time, right? What if I do 13, exactly. Just this time we started at 1, but we're adding 3 every time, right? How about if I do
18. 2.
No, times 2. 32.
32,
Oh, okay.
right? 32, because we're times 2 every time.
Yeah.
Right, the previous one, we're timesing by 2. Or if I do, so this is a question. If I did this, we wouldn't necessarily know. I haven't given you enough information, right? You don't know if it's 27 or 15, right? Am I just adding 6 every time, or am I multiplying by 3 every time?
3.
You need one more, right? If I do 15, then what's the next one? 21, exactly, right? Because you're adding 6 every time. So these are called patterns, right? And what you can do is you can figure out from the pattern what the next sequence is going to be. So what we have is actually we can take these patterns, and patterns like this are essentially what we've been doing with our equations, with our lines and things like that. And what it is as if we have a box with y and x, okay? And here what we're saying is 3, 6, 9, 12, unknown. And x is 1, 2, 3, 4. Right? And so this means, because every step along the way, this is changing. Right? And so we said this will be 15. This actually corresponds to the equation y equals 3x. Do you see that? Whatever x is, y is 3 times it. This one here is, we're starting with plus 1, right? So this one, maybe if we do 0, that'll work better. But this one here is the same as y equals 3x plus 1. Right? Because if x is 0, y is 1. X is 1, y is 4. X is 2, y is 7. See, and this is called a function. When we take a pattern and we make a formula that describes the pattern, it's called a function. Okay? So, say for example, you're buying rice in bulk. Okay? And what the store is saying is 1 kilogram. Okay? 1 kilogram of rice costs 10 shekels. Okay? If you buy 2 kilograms, the cost per kilogram is 10. Okay? If you buy 2 kilograms, they give you a deal. Alright? It only costs 8.5 per kilogram if you buy 2. If you buy 3 kilograms, it costs 7 per kilogram. Alright? If you buy 4 kilograms, it costs 5.5. Alright? And if you buy anything more than that, 5 plus, it costs 4 shekels per kilogram. So the question I have for you is, what is the equation, what's the function to describe how this is changing? And what we look at is we can see that the cost is 10, right? Here, if it's 1, it's 10. If it's 2, it's 8.5. So it's decreasing at a rate of minus 1.5.
Yeah.
Right? You see that pattern. You can see the decrease. So the cost is decreasing at a rate of minus 1.5. Alright. So you could have an equation where basically the rate of decrease, the decrease in rate d equals minus 1.5 times weight, times W. Okay? So that would be your decrease in the amount. So these are some formulas that you'll have. And one last thing I'm gonna ask you. Let me do a picture here. Is let's say one other pattern. Here we have a block of 2. Block of 5. Block of 8. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So first, second, third, fourth. Say you have these blocks. What if I ask you how many blocks are in the 15?
Eight.
So what's the change?
3.
3. We're increasing by 3 each time, right? And so what we look at is in the second one, we have 5, right? So it's 3 plus 2. And the third one,
Eight.
we have 8,
5
which
plus
is
3.
6 plus 2,
Oh,
right? In the fourth one, we have 11, which is 9 plus 2. And in the first one, we have 2, which is 0 plus 2,
yes.
right? So you can kind of see it's 0 plus 2, 3 plus 2, 6 plus 2, 9 plus 2. Okay? So what we need to figure out is the 15th one, what is this number going to be, right? Because it's just going to be plus 2. So first is 0, second is 3, third is 6, fourth is 9. So it means basically second, so it's whatever this number is, 2 minus 1 times 3. Right? So this is 4 minus 1 is 3, times 3 will give me 9. Right? So it's 15 minus 1 equals 14. 14 times 3 equals what? 52. No, 42. You're right, 42. 42. 42. And then we add another 2. 42 plus 2, 44 blocks in the 15th. 44. And if you want, you can try it. If it's 11, then 5th is going to be another 3, 14. 6 will be 17. 7 will be 20. 8 will be 23. 9 will be 26. 10 will be 29. 11 will be 32. 12 will be 35. 13 will be 38. 14 will be 41. 15 will be 44. Right? You can count it. But what we're looking at here is you can see a pattern. What that's basically saying is that this is x. X equals 1, 2, 3, 4, right? Y equals 2, 5, 8, 11. All right? So, we actually have data points here. 1, 2, and 2, 5. So, what I can do is I can get a formula, right?
Yes.
So m equals 5 minus 2 over 2 minus 1, right? x2y over 2. So that equals 3 over 1, which equals 3, right? And then we'll do y equals mx plus b. So let's do this one. 2 equals 3 times 1 plus b. 2 equals 3 plus b. Subtract 3 from both sides. Minus 1 equals b. So my formula is y equals 3x minus 1. Right? So then 15, now x is 15, right? So I put that in, y equals 3 times 15 minus 1,
44.
which equals 45 minus 1 equals 44. You see that? This is math. This is the power of math. I did it kind of quickly because we're running out of time. But I want to just sort of go over it if we have a few more minutes just to look at it. Basically, I'm taking a pattern, right? And from the pattern, I'm making data points, right? And each data point, I can then, because of what we've learned now with our formulas, I can convert it into a equation, a formula. And then using that formula, I can predict. I can tell you what any of them is going to be. Because now I found my formula for this pattern. For this function. Any questions on this? I know it's been a lot. So I encourage you to like go back over and read and to look at the Khan Academy. But yeah, so this week we're going to go over those things. And we'll look at the homework for it, and we'll go over them next week. Have a good week.
Thank you very much.
so much.